Hello and welcome back to one more tutorial in the Gemini series. In this session, I want to bring you the combination of LangChain and Gemini. Though this is not a crash course on LangChain, I want to kick off this discussion with the big picture of LangChain, followed by two specific use cases. The first one is, how do we use LangChain and Gemini together to perform Q&A, which is nothing but RAG? And then we'll also take a look at how we can do summarization with the combination of LangChain and Gemini. So let's get started. First, let's look at the big picture of LangChain. What problem does it solve? And then we'll get into the demos. If you look at the current landscape of LLMs and generative AI, there are many moving parts. First, there are models, which are the large language models, and this could even be multimodal like Gemini. And then we have vector databases. So if you have watched my previous video where I have talked about using Vertex AI vector search, you will be familiar with vector databases. In this specific session, I'm going to touch upon Chroma, but vector databases form one of the important pillars of the generative AI ecosystem. Then we have embeddings. Embeddings are responsible for converting data into a lower dimensional vectors while retaining and preserving their semantic context. Again, if you have watched my previous tutorial, you understand how to convert text into embeddings. And then, of course, it's all about external data. Data lives everywhere. It could be in Google Cloud storage buckets. It could be in BigQuery. It could be in Cloud SQL. It could be your on-prem database. And it's all over the internet. So we need to bring all of them together when we are building powerful generative AI applications. Now, dealing with each of those could be overwhelming, and the ecosystem is fragmented, which means you have to learn different APIs. You have to learn very different set of mechanisms to talk to each of these pillars of the Gen AI ecosystem. Now, LangChain is like a framework. It's like a middleware that sits in between your application and rest of the building blocks of the Gen AI ecosystem and gives you easy access and a very consistent interface to talk to all of these entities. For example, using LangChain, you can load a PDF using a standard technique. It doesn't matter which library of PDF loaders you use, but you can always stick to one API. Then you can use a chunking mechanism offered by LangChain and use a variety of embedding models based on your choice without ever changing your code. And then use a vector database to store the embeddings that you have generated from the choice of your embeddings model. And then again, you can choose from a variety of vector databases without ever changing a single line of code. You only change it once. And then, of course, you can use a variety of LLMs. For example, you can use Palm 2, which is a legacy model offered by Vertex AI. You can use Gemini. You can even use multimodal AI with LangChain. So LangChain becomes this consistent framework to talk to a variety of components in the Gen AI ecosystem. So that is the beauty of LangChain. So in the next two demos, I'll walk you through how to use LangChain and Gemini together to perform RAG and then summarization. Stay tuned. So let's look at setting up the environment. In order to get started with LangChain and Gemini together, you got to create a requirements.txt that has all these components. Now I'm going to publish an article covering all of this, and I'm going to leave the link in the description. But you got to have PyPDF2, Chroma DB, Google Generative AI, LangChain, Google Gen AI, LangChain, and LangChain community. Of course, you need Jupyter if you're using local Jupyter notebooks. So with that in place, let's get started with our very first demo. So the goal is pretty straightforward, as we have seen earlier. We are going to build a RAG application for a fictitious company's handbook called Lakeside Bicycles. So it's an employee handbook, and we want to enable new employees to interact with this PDF by asking questions. Now, if you watched my previous session and followed the hands-on guide, you would remember we have used Vertex AI vector search. Now, I'm going to repeat exactly the same use case, but this time we are going to see how we can do that with Chroma. So let's switch to the Jupyter Notebook and get started. I've already gone ahead and installed all the dependencies. So let me first start by importing the modules. Now, if you're not too familiar with any of these LangChain related components, please do look up LangChain's documentation that has a lot of inputs on how to use these dependencies and libraries. But if you look at this, we are using two modules specific to Google. One is Chat Google Generative AI and Google Generative AI embeddings. And then we are basically looking at LangChain components, including prompt template, PyPDF loader, and so on. We are also importing Chroma, which is coming from LangChain.vector stores. So basically, we have all the dependencies to load the PDF, to convert them into embeddings. This is what it is. And then the vector database to store all of those. And then the LLM responsible for generating the actual response. So we have all these modules, and then I have already gone ahead and set the Google API key. We don't need that, but in case you are actually doing this, you got to initialize your environment by setting up your Google API key. You can get that from Google Gen AI Studio. So the first thing is we will initialize the model, which is Gemini Pro, and then we'll also initialize the embeddings associated with the most recent Gemini Pro. So these two are responsible for converting. One is responsible for converting the text into embeddings. The other one is an LLM. So pretty straightforward. So once we have this, our next step is to load this PDF and split that into multiple chunks. So let's do that with the help of LangChain. So here we are using PyPDF loader and we are loading lakeside handbook.pdf, and we are converting this into multiple pages by calling loader.load and split. So this is basically responsible for converting the PDF into multiple pages. So now if you actually look at what is there inside pages, each page has now become a chunk. And since we have a short, small PDF, we can actually afford to convert that into a single page chunk. But if you have a large PDF and you want context to be preserved at a more granular level, you can use different techniques. But for this demo, I am going by page. And once we split the PDF into multiple pages, then the next step is pretty straightforward. If you remember my previous demo, we have done this manually, and here we are taking advantage of the LangChain libraries. So now we are actually saying vector DB is Chroma from documents, and we are passing the pages that we have just split, and the embedding scheme is based on embedding 001 model offered by Google. So that's it. Now this is going to take a few seconds because this step basically converts these pages into embeddings. And once that is done, you can take a look at what is there in vector DB. So this is now representing Chroma. So that's what it is really meant. Now once we have that, we can define the vector DB as a retriever. So remember, in RAG we have two components. One is the retriever, the other one is the generator. So here we are defining the retriever. So vector DB as retriever, and search args are set to 2, which means we want to retrieve two different chunks, two different nearest neighbors. So that defines the retriever. And then we have to define what is called as the retrieval chain. Remember, LangChain is all about creating chains. And in this context, what we're going to do is we have multiple components that form as a chain. We have the prompt, we have the context, and then we have the LLM. So we have to put all of them together like a pipeline, like a chain, and then execute them. So to start with, let's define the template. The template is the very first part of the chain. And then we will basically instantiate a prompt from this template. And here, if you notice, we are saying your helpful AI assistant answer based on the context provided. Context is this, input is this, and you come back to us with the answer. So that's what the template is all about. And then what we need to do is, first we have to create a chain that wires the LLM and the prompt. So this is the first step. But remember, this is going to be incomplete because the prompt in itself doesn't have the context. So the next line of code essentially does that. Now what it does is, it basically takes this chain and adds the retriever to it. And where is the retriever? Well, the retriever is the vector database. So let's run these two cells. So the retrieval chain is now in place. Now it's all about invoking the chain. So first we will basically define the retrieval chain, or rather invoke the retrieval chain by asking how many days of personal vacation in a year. So that is my basic chain. So when I actually send input, I am populating this. But we also need to populate the context. So what happens is, because we created the retrieval chain, this is going to be populated at runtime. So we don't need to do that manually because we have already defined the chain and we are invoking the chain. So LangChain is smart enough to figure out that retriever is going to be populated into the context, and it automatically does that. And this is a well-defined prompt, and this prompt is what is required when you are performing a retrieval chain. So let's now go ahead and invoke this. Now this is going to basically come back with the response. So let's print this. Now this is a pretty large payload. Now if you see what is the input, this is the input. Context, because we have mentioned 2, it basically took 2 pages into the context. So page 0 and then page 1. So it has taken both these pages, and that is what has been sent to the LLM. Now this is pretty long, but I want to go ahead and print the actual response. So let's comment this out. We don't need this long response. So now we will go ahead and print the actual answer, 10 days. So if you actually look at the PDF and go back to the leave policy, yes, you are eligible for 10 days of personal leave. Perfect. Now let's repeat this by changing the query. So according to the handbook, the HR policy says the employee can take an online course up to $500 per year. So that's exactly what I want to ask. What is the cost of online course that I can take? So let's generate this. Perfect. So it comes back and says the organization will cover up to $500 per year per employee. Now let's try one more query before concluding this demo. So how do I apply for a sick leave? Now this is an important question, and if you look at the sick leave policy, you got to notify your supervisor, provide a medical certificate if needed. That's exactly what our RAG, LangChain based RAG application is saying. You must notify your supervisor and then provide a medical certificate. Perfect. So if you have watched my previous video, and if you are looking at this is exactly the same use case, but look at how simple it is to use LangChain. Now the beauty of LangChain is you can switch this to any of your favorite vector database. For example, I can switch this to Milvus or VV8 or Fires or anything without changing my code. So here, because I'm calling this as Chroma, I'm using Chroma from documents, but here I can replace this with fires, and then I can say fires from documents, and boom, everything remains the same. So that's the beauty of LangChain. It's a middleware that abstracts away the underlying components by keeping the API very consistent. So that concludes the first demo of this session, which is implementing RAG with LangChain and Gemini. In the next demo, I'm going to walk you through how to perform document summarization. Stay tuned. All right, so we are on to the second demo of this session, and the objective of this demo is to walk you through how you can perform summarization with LangChain and Gemini. So I want to take an existing article. For example, one of my recent articles talks about the building blocks of LLMs, what are vectors, tokens, and embeddings. And similarly, last year I wrote an article on how do we reduce hallucinations from LLMs. So my goal is to take these articles and perform summarization. So let's see how this works. Now I'm going to start by importing the modules and then initializing the LLM. That's the first step. So if you haven't really been familiar with this, now this is how you initialize an LLM in LangChain. This can be any other model, but at this point we are focused on using the chat Google generative AI. We actually don't need embeddings, but there is no harm. We'll leave that as is. And then what we'll do is we'll now use a different loader. Last time we used a PDF based loader, but this time I'm using a web based loader, and we are pointing to this URL, which is this article. So we load this. Now when we run the cell, now if you look at the docs variable, it contains all the HTML, not exactly HTML, it has cleared or it has cleaned up all the HTML, but it has all the text, everything that we need. So that is exactly what we need. Without LangChain, doing this is very painful. So let's comment this out. Now, once we have the content loaded into a variable, it's pretty straightforward to define the summarize chain. So again, we start by defining a prompt template. So we will first define the prompt. So write a concise summary of the following, and then we provide the text. And our goal is to populate this text. So with this template, we will define a prompt. That's the first step. Now, once we have the prompt, then remember how we created an LLM chain. So the LLM chain contains nothing but the LLM and the prompt. And the LLM is Gemini in our case. And then we have to basically expand this chain to include the stuff chain, which is basically how you perform summarization. So here we have the stuff documents chain, the LLM chain that we defined here, and then the document variable name is text. And that is what is being sent into this template as the context. So now we have to invoke the chain. So when you actually invoke this chain, you pass docs. And where is docs coming from? Well, here is our docs. So now this replaces the text. That's exactly how we create placeholders in LangChain and eventually replace them with the actual content. I didn't run the above cell. Let me run that. Okay. So now this is done. And we are almost done with this demo. This is pretty straightforward. So now it's going to take a while, but once it is done, look at the response. So now the response has input document. It has basically taken this entire article content, and then it came back with the response, which is the summary. So now you can print the output text, and there we go. So This article delves into the foundational concepts of vectors, tokens, and embeddings, which are crucial. So this is pretty cool. Now, if you want, you can change the prompt a little bit. Write a concise summary in, let's say, 200 words of the following. So now we are changing the template to increase the number of words. Let's actually turn this to 300 words. So now let's run the chain again. And this time we're going to see a longer output. It's a decently long article. So now when we look at this, okay, definitely, this is definitely much longer than what we have seen. So let's print this to avoid the new line characters and all of that. Okay, perfect. So now we have a more detailed summary. It actually calls out what are vectors, what are tokens, what are embeddings, and then the relationship. Perfect. So now I'm going to do the same thing with another article. So I'm going to grab this URL and we will feed that and run the entire thing. So now we can actually say, let's restart the kernel and run all the cells. So now this is going to come back with a summary of my hallucination article. So this is even longer than the previous one. So it's going to take a few more seconds, but there we go. So here is the summary. So it basically says LLMs tend to produce text that is that appears to be correct, but it may be false. These are called hallucinations, and you can reduce by using one shot, few shot, and context injection. So those are the techniques that I touched upon with examples, and that's exactly what the response has been. Perfect. So that's how easy it is to integrate LangChain with Gemini. And we have seen two different use cases. One is basically the Q&A, which is RAG, and the next one is summarization. You can change the loader from web-based to maybe a PDF or a CSV, or you can use any source, but rest of the code remains exactly the same. That's the advantage of using LangChain. Well, that brings us to the end of this session. I hope you found this useful. And in the next session, we will take a closer look at the multimodal AI capabilities of Gemini. It's going to be very interesting, where I'm going to show you how to generate embeddings for images and text together, and how do you perform semantic search on images using Gemini. So stay tuned, and if you haven't subscribed to my channel, don't forget to subscribe, and please like the videos. It helps me in showing it up in the playlists and YouTube recommendations. So this entire series covers end-to-end of Gemini model. So the next two sessions are going to be pretty interesting. As I mentioned earlier, the next session is all about multimodal, and then the last session is going to be about building agents and function calling with Gemini. So don't forget to subscribe and stay tuned. Thank you.